Hey guys, Mr. Riss here, and just to help you out, in the next part of the 2.5 guided notes, we're going to be doing implicit derivatives, but now we're going to be evaluating them at a point. So normally when we try to find the slope of a graph using the derivative, we take the derivative and then we plug in the x value. But now we're using implicit derivatives, which means we have an x and a y in our derivative, and you could see we would have dy dx's or derivatives that would have like 2x over 5y minus 3. All we need to do to find the slope, which we still can, is just to plug the x where the x is and then plug the y where the y is. So let's go through normally, take the derivative like we did last time, but now we're just going to add that extra step at the end today. So if I wanted to take the derivative of x to the 2/3 power, that would be 2/3 x to the negative 1/3 power. And then plus the derivative of y to the 2/3 power is 2/3 y to the negative 1/3 power. But we took the derivative with respect to x, so we must add a dy dx at the end of this. Okay, so now this is equal to the derivative of 5 is 0. So remember, when we take the derivative, we need to isolate the dy dx, so everything else is going to move over to the other side. And just to make this a little bit easier, this is really 2/3. This doesn't have, so this is going to be 2/3 times, you know what I'm going to do, times the cube root of y on the bottom, dy dx, is equal to the negative 2/3 times the cube root of x. Because if I move that over to this negative. All right, so let's talk about this here. If I wanted to go ahead and we can do a couple things here. If I wanted to get rid of the 2/3, I'd multiply by 3 over 2. So these are going to cancel each other out, because if I multiply by 3 to get rid of that divided by 3, it would cancel out here. If I divide by 2, it would cancel out the 2 there. Really, all I need to do here is to multiply by the cube root of y to get that off of here. So I'll multiply by the cube root of y. And so that means dy dx is equal to the negative cube root of y over the cube root of x. Okay, so that's the derivative like we would have done yesterday. Now all we need to do is to take that extra step. We're going to plug in 8 for x and 1 for y. So the slope would be negative cube root of 1 over the cube root of 8. The cube root of 1 is 1, so this would be negative 1 over the cube root of 8 is 2. So the answer would be negative 1/2. So this would be a slope of negative 1/2. Okay. Let's do the next one here. Just more practice so we get good at this, and we'll take a look at the homework problems. Determine the slope if we got 3 of x plus y squared equals 100. Okay. First off, this first part is a chain rule because we have this x plus y squared inside of a squared. So we have 3 of something squared. So the derivative of that would be 6 of that something, which is x squared plus y squared, to the first power. And then we're going to times by the derivative of the inside. The derivative of the inside, the derivative of x squared is 2x. The derivative of y squared is 2y dy dx. Okay, so that's just this part here. Now on the other side, we have 100xy. 100xy would be 100x times y. We got to do the product rule for that. So derivative of 100x is 100. We leave the y alone. All right, then plus. Now we are going to leave the 100x alone. We'll take the derivative of y, which is 1, but we'll have to put a dy dx. Okay, so if we wanted to go through and simplify this, really we need to distribute the 6x squared plus 6y squared to the 2x plus 2y dy dx. And then we still have our 100y plus 100x dy dx. We got to move a lot of things around here. So let's distribute all this mumbo jumbo here. Well, yeah, we'll do that. I guess we don't have to, but it might be easier. So if I distribute the 6x squared, I'd get 12x cubed plus 12x squared y dy dx. All right, now distribute the 6y squared, I'd get plus 12xy squared plus 12y cubed dy dx. And this is still equal to the 100y plus 100x dy dx. Okay, so let's move everything around. So this is going to move over to that side, it's going to move over to that side, and then this thing needs to move over here. So we would have a 12x squared y dy dx and a 12y cubed dy dx, which my handwriting was a little neater, minus 100x dy dx. I moved that over here. Okay, now these are gonna move over, they're gonna be negative, so I'll start with the positive, equals 100y minus 12x cubed minus 12xy squared. Okay, so finally here we can get the derivative. I'm gonna write it up here where I have a little bit more space, but dy dx, because we're gonna factor that out from here, and whatever we have left over, we'll divide the right side, is 100y minus 12x cubed minus 12xy squared over 12x squared y plus 12y cubed minus 100x. Okay, now normally what we would do, if we were just finding the derivative, we would divide by some constant term. I think we can divide everything by 4 here. Yeah, we can. But since we're just finding the slope, we're just going to plug in our numbers and we'll simplify it in the end. So let's go ahead. We're going to plug in 3 for x and 1 for y. So this would be 100 minus, okay, if we plug in 3 cubed is 27. I'm going to have to get a calculator here because I don't want to do 27 times 12 in my head. I mean, I probably could do that. It's 270 plus 54. And was it 324? Where's my calculator at? Here we go. A little handy dandy red one here. That's all I need. Okay, let's say that again. So 3 cubed is 27. 3 times 3 times 3 times 12. Yep, 324. So minus 324 minus, okay, 12 times 3 times 1 squared, that'd be 36. All right, all over. Okay, now the bottom here, we got 12 times 3 squared times 1. So 12 times 9 is 108. All right, plus 12 times 1 cubed, that's just 12, minus 100 times 3, which is 300. So you just plug those numbers in. All right, let's see what we get in the top. We get 100 minus 324 minus 36. We get negative 260. Over on the bottom, we got 108 plus 12, that's 120, minus 300, that's what, negative 180. And now that does reduce, and so we can just do 260 divided by 180. We get 1.4 repeating, which if we go math, enter, enter, what is that, second F to D, second ABC on here, 13 over 9. All right, there we go. So that one was really complicated, and that's why we put it on the notes and not on the homework here. But you can see here, all we did is we take the derivative and then we just plug the x and y. So really this is more of a practice of making sure we can definitely take the derivative, plugging in the x and y isn't too bad. Now just to show you guys too on your homework that you guys will have to do, I'm stolen from here. When you have graphs, they do the same thing. You're just going through, like if I want to find the slope at this point here, I mean, yes, we're going to go ahead and plug it in, but really you should just remember here, you're going to take the derivative of this, plug in your x, plug in your y. And if you look at the graph should help you out because you should see that here, the slope should be some kind of negative slope, right? That's a negative tangent line that we could draw there. So you should have a negative slope. Anything else like here in number 30? Looks like that graph would be going up. The tangent line would be like so. It should get a positive answer. So that should help you out a little bit. Give you a general idea if you did this right or wrong. Remember too, we do have the answer keys online that you guys can check, but you must show your work. All right, so this is going to wrap up 2.5. 2.6 we're going to spend a lot of time because 2.6 is basically, it's 2.5 but story problems. So we'll spend a lot of time on that and it should be a lot of fun. You guys have a great day and I will see you guys next time.